Hey guys, welcome back. We got day 17, and all this is examples. So my recommendation, if you haven't already done this or tried this, is to attempt it yourself. And then follow along afterwards, and then make sure you're right, and go from there, okay? That's my recommendation. All right, so now I'm going to start, and let's dive in. First thing I look at what type of elements do we have here. Na, where is that at in the table? So you got to have your periodic table out. Got to have the periodic table out. And Na would be a metal, group 1. And then Cl, chlorine, is a non-metal, group 17. So opposite sides of the periodic table, far apart, opposite sides of the stairs. That's going to be, this is an ionic compound. All right. And if I look, I got lithium and potassium. If I go down, they're all metals on the left and all non-metals on the right, or polyatomic ions. So that means we have ionic compounds. Now, if I look at these metals are all in group 1 and group 2. So there's no need for Roman numerals because we know their charges. Okay? So what is NaCl? Well, that's sodium and chloride. Not sodium chlorine, but sodium chloride, right? Remember, the ending changes to "ide." Lithium fluoride is the next one. You got potassium, chloride, calcium, oxide, magnesium, sulfide, strontium, iodide. Now, this next one. I've seen this written many different ways. The key to this one is recognizing I have that, and the next 4. And those are, of course, your polyatomic ions. And because they're polyatomic ions, we use them in the name. So we have sodium and nitrate. Sodium, again, and hydroxide. Potassium, phosphate. And magnesium, sulfate. And so those are some examples of going from the formula to the names of ionic compounds that do not need Roman numerals. Nope. Now we're going the other way. So now I have the name of a compound, and I have to determine the formula. All right, and this is the more common way we do things, and it can also be difficult. All right, so first, again, I have to recognize what type of compound do we have. Do we have molecular compounds, or do we have ionic compounds? Well, if I look, I got potassium, which is a metal, fluoride, non-metal. Those would be ionic compounds. So I'm going to put ionic down. And potassium, lithium, sodium, silver, magnesium, calcium, potassium, sodium. No Roman numerals are needed. All right, so potassium. I would, go ahead and write this out. Potassium is K. Group 1 metal, it's +1. Fluoride, F. Group 17 halogen, -1. They're good together, KF. Lithium chloride, Li. Group 1 metal, +1. Chloride, Cl-. So it's good, LiCl. I would recommend writing these ions like this, even though they're 1-to-1 right now because they're going to change. But I would recommend that just so that we know what's going on. All right, you know what's going on. Sodium bromide. Sodium is Na+. Bromide's Br-. So that'd be NaBr. Silver oxide. Silver is Ag+. Oxide, O2-. Uh-oh. This 2 comes down, right? And we're going to cross charges. And the 1, we don't write the 1. So we actually get Ag2O for silver oxide. Magnesium phosphide, magnesium, Mg2 plus, phosphide, P3 minus. So it looks like I get Mg3P2. Calcium hydroxide, Ca2 plus, group 2 metal, hydroxide, polyatomic ion, OH minus. So with this, we are going to put the 2 down, but I have to go Ca. If I just write this, that's not going to work. I have to do the parentheses for calcium hydroxide. 2 hydroxides. Potassium, K plus, dichromate, Cr2O7 2 minus. Cross charge, how about K first? K2 Cr2O7. Now we don't need parentheses around the dichromate because there's only one of them. Sodium hypochlorite, Na, positive, hypochlorite, ClO minus. So this becomes NaClO. And then we have sodium bicarbonate, Na plus, bicarbonate, HCO3 minus. So NaHCO3 is sodium bicarbonate. I got more. Magnesium, Mg2 plus, phosphate, PO4 3 minus. So I get Mg3PO4 2. Ammonium, NH4 plus, nitrate, NO3 minus. So that's good. And if we don't know our polyatomic ions, we just can't name that one. In Chem 1 here. Sodium acetate, Na plus acetate, C2H3O2. So NaC2H3O2. Now, if you wrote it and you learned before, you can write it this way. Or even in Chem 1, I always write it the first way. In Chem 2, or try to. In Chem 2, I almost always write it the second way. All right, so that's 2 sets of ionic compounds that do not need Roman numerals. Let's look at number 3 now. All right, number 3. We have chromium, and chromium's a metal, and phosphate's a nonmetal. So these are ionic, but these are going to need the Roman numerals. Now, it's chromium and phosphate. The question is, what Roman numeral does chromium get? Well, we know phosphate is -3. And if you look about uncrossing charges, there you go. So chromium has to be 4. Right? Because 3 plus 4s and 4 minus 3s, right? So plus 12 and minus 12. The next one, copper and nitrate. Copper something nitrate. In fact, C is also copper something nitrate. And what I caution you on, nitrate here is -1. So that means copper has to be 1 here, and copper has to be 2 there. Right, so it's copper 1 nitrate and copper 2 nitrate. Because copper is +1 in B, in C, copper has to be +2. Because you got 2 nitrates. D, I got iron and oxide. Well, oxygen, of course, is -2. So that means iron has to be +2. E is also iron something oxide. Since oxygen is -2, that means if I look at doing all this, iron has to be +3. All right. And again, practice this, practice this, practice this. Manganese and sulfate. So Mn. Manganese something sulfate. Well, we know sulfate itself is -2. That means manganese should be +2 in this situation. The next one's a manganese with oxide. So we put manganese oxide down. All right, and oxygen again is -2. So it means manganese looks like it's 3. All right, now we're just learning this, right? We're just learning that, and it's okay to go slow. However, I'm going to preface this. Practice this enough. This is a fundamental, especially if you're taking more classes, right? If you're going to take Chem 2 and maybe organic chemistry or whatnot, however far you get to go, practice this and become very proficient at it. That's a very, very good key to success. So H, tin and chloride. Well, chlorine is -1. All right, and since there's 2 chlorides, I have to have tin be +2, or 2 plus, to make this work. The next one, tin and chloride. Well, again, chloride's -1, so I have to have tin 4. J, I have lead, something oxide. Well, oxygen is -2. All right, again, use your periodic table. You're always able to use your periodic table. So if I have lead, if oxide is -2, lead has to be +2. And then K, I got lead, something oxide. And since oxygen is -2, and there are 2 of them, lead has to be 4. Right, because this was probably Pb2O4 reduced to PbO2. This next one, W is tungsten, something carbide. Well, carbon would be -4, so tungsten 4 carbide. Oh, good, and that's all of those. So that's all of those, and now we're going to go the other way. Again, these are ionic, but we need Roman numerals. So chromium 3, again, I would write down, this is the +3, right? Cr3 plus, chloride, Cl minus, and so if I cross my charges, I get CrCl3. Nickel 2 bromide, nickel 2, Ni2 plus, bromide, Br minus. So if we do this, I get NiBr2. Vanadium 5. So vanadium V, 5 plus, sulfate, SO4 2 minus. So it looks like I get V2, SO4 5. Lead 4 carbonate, Pb4 plus, CO3 2 minus. So it might look like I'm going to get Pb2, CO3, 4. But that is reduced. We reduced ionic compounds to Pb, CO3, 2. Copper 2 sulfite, Cu2 plus, sulfite, SO3, 2 minus. They're good. So CuSO3. Palladium 2 nitrite, Pd 2 plus, nitrite, NO2 minus. So I get PD, not PB, PD, NO2, 2. Platinum 2 nitride, PT 2 plus, platinum 2 nitride, N3 minus. Right, that's an element. Typically the ides are elements, not always, but usually. But not always. So I get PT3N2. And titanium 4 oxide. Ti4 plus, O2 2 minus. So if you notice that, you notice it's going to be a 2-to-1 ratio of titanium and or of oxygen to titanium. And if we cross them, you get Ti2O4, right? But maybe you can go bypass that and just go right to TiO2. Right? So there you go. And this right here, number 4, is probably the hardest part about the class. Right? I'm not exaggerating. I'm not trying to make fun of it or make light of it. It really is one of the challenges with the class. And it's a language. It's not math. I highly encourage you to practice until you get very proficient at it. The further you have to go in chemistry, for sure. Number 5 is now molecular. Right? Tells you molecules. First one, H2O, water. This one, hydrogen, sulfide. Right? Because we don't denote the number of hydrogens normally. However, if you write dihydrogen, monosulfide, I would not mark it wrong. NO2 is nitrogen dioxide. P4S6, tetra, phosphorus, hexa, sulfide. PCl3, phosphorus, trichloride. NF3, nitrogen, trifluoride. CO, carbon monoxide. And CO2 is carbon dioxide. Six, hexa. P, phosphorus. Decaoxide. Now, if you write decaoxide, I'll be fine. It's not really decaoxide. The A's dropped, but for me, I'm not worried about it. All right, so that's why the A is in pink, because it's really not there, but if you write it there, fine. Not a big deal. 7, right? Hepta. Nitrogen. 9 is nona. Bromide. Now, typically, these seem to be easier than the ionic ones. For whatever reason, just because we're doing prefixes tell us the number, okay? And that's the case for you, great. If it's not, that's okay too. All right. All right. Now we're going the other way. Hydrogen sulfide, that's H2S. Silicone tetrahydride, SiH4. Right? Oxygen difluoride. Oxygen's O, difluoride, F2. Hexasulfur, right? S6, nona oxide, O9. And I left the A in there for you guys. Tetranitrogen, N4, pentachloride, Cl5. Tricarbon, C3, heptasulfide, S7. Carbon monosulfide, CS. There we go. All right, there's some molecules to formulas. And the last little bit of naming we're going to do. We got the 7 strong acids and then a weak acid that's very common in Chem 1 and 2. Sulfuric acid, right? It came from 8. Right, these are acids. Hopefully we got that from the name. So sulfate is SO4 2 minus, so that means I have to have 2 H's there. Nitric comes from nitrate. Nitrate is NO3 minus, so I need 1 H. Perchloric acid, perchlorate, is ClO4 minus, so I need 1 H. Chloric acid is chlorate is ClO3 minus, so I need 1 H. All right, and so all these, I'm going to erase the charges because there's no charges on these, right? Those are the acids, but that's how it's done. So if I would write out the polyatomic ion for those if you need to, right? So I would have SO4 2 minus here, NO3 minus, ClO4 minus, ClO3 minus, okay? Now we have hydro. Hydro means there's no oxygen. So hydrochloric is hydrogen chloride. HCl, hydrobromic, hydrogen bromide. Hydriodic, hydrogen iodide. Acetic comes from acetate, which is C2H3O2 minus. And so for this one, it's HC2H3O2. And remember, those red ones are your strong acids. All right. One last little thing I like to do for students is this little review, because it's been a hot minute since we touched on this. So I want to know the number of protons, neutrons, electrons, and the charge of these things, and see if we can come up with them. All right. Again, hopefully you tried this before watching. All right, but let's go through it. Protons. Number of protons, right there, right? That's the atomic number. 92 protons. Neutrons, right? You subtract 235 minus 92. I think that's 143. Electrons. I have 3 more positives than I do negatives, so it looks like it's 89. And the net charge would be 3 plus, or plus 3. Either way, I'm happy however you write it. Next one, iron. Looks like we have 26 protons. Looks like we have 56 minus 26, 30 neutrons, and 3 more positives and negatives. It looks like that would be 23 electrons, and then the charge would be 3 plus or plus 3. Xenon, there's no charge, because I tell you there's no charge. Protons, 54. Neutrons, 131 minus 54, is that 77? And electrons should be the same because there's no charge, 54. Next one, 80. Well, who is 80? If I put 80 down here, I go my atomic number, that looks like it's Hg. Now, it's 2 plus. So that means I know how many electrons. Should be 78, right? 2 less negatives than I do positives. The neutrons. Well, it depends on what I put for the mass. If I put 200, I can put 200, right? Because it's 200.59. I can put 201 down. Right? And it matters. Because if I put 200 down for the mass, I have 120 neutrons. But if I put 201 down, I have 121 neutrons. So it depends on what we put down for the mass to actually get the neutrons right. This next one has neutrons of 117 neutrons. It has electrons of 76 and a plus 2 charge. So how many protons then would it have? Well, I think it would have 78 protons. And who has 78 protons? That would be platinum. Now, 78 goes down here. What number goes where the mass is? Well, you have to very carefully add these two up and put it up here, right? You got to add those up, right? Which is, what is that? That would be 195, wouldn't it? Yeah. Now, that happens to be what's on the screen, or the periodic table as well, 195, but it doesn't have to be. All right, so you got to add them up. Next one, 74. That's W. And it's 6 plus. 74 down here. What's our neutrons? What are the neutrons we're going to put? Well, I would use 184 for my mass, right, which gives me 110 neutrons. You can use a different number, right, because it's technically 183.85, so you can do 183. You get 109 neutrons. It doesn't matter to me, it's just they got to match up. Electrons. Well, I have 6 more positives than I do negatives, so it looks like it's 68. All right. Last one. -2 charge, and I have 8 neutrons. Wow. What one of those elements in the small elements have 8 neutrons? Well, looking from carbon to neon.